Now we shall start to important concept. One is linear Diophantine equation and fundamental theorem of arithmetic. And this is our fourth class of integer. So now we have to know about the linear Diophantine equation first. So first recall one. This is what is exactly mean by the linear Diophantine equation. Linear Diophantine equation. So a linear Diophantine equation or linear Diophantine equation of the form is of the form x plus by equals to c, x plus by equals to c, and while a square plus b square, while a square plus b square, this is basically non-zero. And a, b, c all are integers. And the example is, as for example of a linear Diophantine equation, say 2x plus 4y equals to 6. This is an example of a linear Diophantine equation. Now the question is how to solve this kind of linear Diophantine equation that we discuss here. So here the first, next recall 2. And the fact is related to the theorem. If ABC are integer, if ABC belongs to Z with a square plus b square is non-zero. That means at least one of them is non-zero. Then the equation, then the linear Diophantine equation, then the equation x plus by equals to c has an integral solution, has an integral solution, that means solution in integers, integral solution. If and only if d divides c. What is d? Where d is equals to GCD of AB. Okay. So what you will do? So if you have given the linear Diophantine equation in that form x plus by equals to c, where a square plus b square is non-zero and a, b, c are basically all integer. So what you have to check? You have to check first. You will calculate GCD of AB, and that may be D. Say this will be step 1. Step 2, what you will check? D divides C or not. Okay. So if yes, D divides C, then step 3. That means the equation has x plus by equals to c has integral solution. Integral solution. Now the question is, what is exactly meaning of the terminology integral solution? If x0, y0 belongs to z cross z be such that it satisfies the equation x, so x0 plus by0 equals to c. Then x0 y0, that solution is called integral solution and integral solution. Okay, that means both the component are lies in integers. Now here is one important note. The note is, if x0 y0 be any particular solution, if x0 y0 be any particular solution, of the equation of ax plus by equals to c, where a comma b comma c belongs to z and a square plus b square is non-zero, then all integral solution is given by x0 plus b by d, given by x0 plus b by d into t, comma y0 minus a by d into t, such that t is basically belongs to z and d is basically GCD of AB and that divides c. And here x0 y0 this is basically integer solution, so that belongs to z cross z. Okay, so this is one of the important theorem, but here again important corollary. If GCD of AB equals to 1, that means D equals to GCD of AB equals to 1, that means A is prime to B, then all integral solution of the equation, of the equation, Diophantine equation, x plus by equals to c, where all ABC are integers and a square plus b square is non-zero, is given by that is equals to x0 plus bt comma y0 minus at, such that t belongs to z and GCD of AB equals to 1, but where x0 y0 that belongs to z cross z is any particular solution. So now we come to the different problems of Diophantine equation. Just for example, how to solve, how to find out. So next recall 2, 3 and this recall 4. Recall 4 is basically integral solution of the equation. Integral solution of the equation x plus by equals to C, where A, B, C are positive integers, where A, B, C all are positive integers, Z plus, and GCD of AB, this is equals to 1. Here Z plus are basically set of all positive integers, and GCD of AB is 1. So now how to solve this kind of problem? Okay, so here you have asked the question, find the general question, find the integral solution of the equation of the Diophantine equation x plus by equals to c, where all ABC are set of positive integers and ABC belongs to set of positive integers and GCD of AB equals to 1. You have also asked this kind of question. Now the thing is how to solve this kind of question, or how to solve this kind of linear Diophantine equation. What is exactly given? The given Diophantine equation is x plus by equals to c. What is ABC? Where all ABC belongs to set of positive integers and GCD of AB, this is equals to 1. Okay. So start, since GCD of AB equals to 1, that implies there exists integer u comma v belongs to z such that AU plus BV equals to 1. And therefore, what is exactly given? It is given x plus by equals to c. So now we have x plus by equals to c, that we can write x plus by equals to c multiple 1. That we can write x plus by equals to c in position of 1, we can write AU plus BV. This is AU plus BV by 1. Okay, and from that we can write A into x minus cu equals to minus b into y minus cv. Okay, now since A and B are prime to each other, since GCD of AB equals to 1, that means they are prime to each other, so we must say x minus cu is divisible by b and y minus cv is divisible by a. So therefore from 2 what we can write? We get x minus cu by b minus b, this is equals to y minus cv by a. So that means what we get? Therefore x minus cu by minus b, this is equals to y minus cv by a, and because the x minus c is divisible by b, y minus cv is divisible by a, so it must be an integer. So we just consider, say, t, say, what is t? Where t is basically an integer, t belongs to z. So that means it implies x minus cu equals to minus bt and y minus cv equals to at, and that implies x equals to cu minus bt and y equals to CV plus AT, where t is an integer. Okay, so this is the general solution. Thus, the general solution is x equals to cu minus bt and y equals to cv plus at, and where t is basically integer, so 0, plus minus 1, plus minus 2, plus minus 3, and so on. This is our general solution. But here is one important note. If you have asked the positive integral solution, so for positive integral solution, we must have x and y both belongs to z plus, both will be positive. Okay, so that is x is strictly greater than 0, y is strictly greater than 0, and that is x means cu minus bt is greater than 0, and cv plus at, that must be greater than 0, and that will hold simultaneously. So that is here minus cv by a less than t less than cu by b. Okay, so for positive integral solution you must have this condition. So now the question is, find the general solution in integers of the equation. We'll do one problem. This problem is important. That problem has been asked in Calcutta University Honors Examination, B.Sc course. What was the question? The question is, find the general solution. Find the general solution in integers of the equation. In integers, that means both the components will be integer of the equation 7x plus 11y, this will be 1. So you have to find out the general solution in integers. So this is obviously Diophantine equation, and here the GCD of A and B, GCD of 7 and 11 is 1. So it must have a solution. So here the given Diophantine equation is 7x plus 11y equals to 1. Okay. So now we just compare with x plus bi equals to c. Since GCD of 7 and 11 equals to 1, that implies there exists integer u comma v belongs to z. So AU, that means 7u plus BV, 11v equals to 1. Okay. So now you just apply the division algorithm or Euclid algorithm, and you will check here u equals to 8. Here you can write here u equals to 8 and v equals to minus 5. That you can check with the help of division algorithm or Euclid algorithm. How you will check? So just you will divide 7, 11, 7, next 4, 7, 3, next 3, 4, 1, 1, 3, 0. Okay. So you will write here 11 equals to 7 into 1 plus 4. 7 equals to 4 into 1 plus 3. 3 equals to 4 equals to 3 into 1 plus 1, and 3 equals to 1 into 3 plus 0. So last non-zero integer remainder is 1. So that means GCD of 11 and 7, this is basically 1. And from that we can calculate, just move to reverse. So 1 equals to 4 minus 3 into 1. Just to put the value of 3 here. So 4 minus 3 means 7 minus 4. And after that, we just change the value of 4. So this will be 2 into 4 minus 7. Then 4 means 11 minus 7. So 2 into 11 minus 7 minus 7. So that means you can write here, okay, 11 into 2 minus 7 into 3. Okay. So that is also the solution. Again, you can check here in that case, here your u equals to 2 and v equals to minus. So this is also the possible solution. Also you can put u equals to 8 and v equals to minus 5. Okay, so then now what is exactly given? 7x plus 11y, this is equals to 1. And that we can write 7x plus 11y equals to 7 into 8. 1 means 7u plus bv. So 7 into 8 minus 11 into 5. Also you can write here, also you can write in that position 7x plus 11y. This is basically 11 into 2 minus 7 into 3. That you can write. So either you can write this one or you can write this one. The solution remains same. Okay. So now from that you can write 7 into x minus 8, and that will be 11 into minus 11 into y plus 5. Now since GCD of 7 and 11 1, so that means we can write x minus 8 by minus 11, y plus 5 by 7. This is equals to some t, where t is basically integer. And since GCD of 7 and 11 equals to 1, so 7 must divides y plus 5 and 11 must divides x minus 8. Okay, and from that we can write x equals to 8 plus minus 11t, and y equals to minus 5 plus 7t. What is t? Where t is basically integer, so t equals to 0 plus minus 1 plus minus 2 and so on. So here the general solution in integers, therefore the general solution in integers is given by x equals to 8 minus 11t and y equals to minus 5 plus 7t. What is t? Where t is basically integer, either 0 or plus minus 1 plus minus 2 plus minus 3. Now if the question is like this, very important question is like this: find all positive integral solution. Positive, I said positive integral solution of the equation of the Diophantine equation 7x plus 11y equals to 1. Okay, So here it is as positive integral solution. So you just do the previous part, what is exactly given in question 1, what we have done. So here we get the general solution. The general solution is in integers is given by, that we have done in previous problem, x equals to 8 minus 11t and y equals to minus 7 plus 7t, where t is basically integer 0 plus minus 1 plus minus 2 and so on. Now in our question it has been asked the positive integral solution. So what we will do for positive integral solution, for positive integral solution, x is obviously greater than 0 and y is obviously greater than 0. So that means we have 8 minus 11t is greater than 0 and minus 5 plus 7t greater than 0 simultaneously. Okay. So that means here we have 5 by 7 less than t less than 8 by 11. Where what is t? Where t is belongs to integer. But there is no such integer t exists between 5 by 7. So here 5 by 7, here 8 by 11. So there is no such positive integers on the real line in between 5 by 7 and 8 by 11. So no such positive integer exists. So no such integer or t exists in the interval 5 by 7 comma 8 by 11. So that means hence there is no solution of the equation in positive integer. So thus there is no solution of the equation 7x plus 11y equals to 1 in positive integers. Okay, so now we will continue another important problem. So this is MCQ problem. The number of positive integral solution of the Diophantine equation 7x plus 11y equals to 1 is, option is 0, that is no positive integral, option B1, option C2 and option D infinite. So obviously that is no positive integral solution that we have shown in the previous problem. Okay, 7x plus 11y equals to 1. So the explanation is already done here. Okay, we solve it. This is the general solution. For positive integral solution, you need to satisfy this condition. Okay, there is no such integer t lies between 5 by 7 and 8 by 11. So no such t exists. So that means there is no positive solution, no positive integer solution of the equation, or no solution of the equation in positive integers. Okay, now we come to the next question, question number 4. So here you will see question 1, 2, 3, the same equation, but the pattern of the question are different. So now we'll move to the question number 4. Find the general solution in integers. Find the general solution in integers of the equation 5x plus 12y 5x plus 12y equals to 80, and examine if there is a solution in positive integers. And examine if there is a solution in positive integers. Okay, so now we come to, first we'll find out the general solution, and next we will find out the solution in positive integers. So solution. So the given equation is 5x plus 12y equals to 80. This problem is also important. So since GCD of A and B, that means 5 and 12, this is basically 1. So this implies there exist integers u comma v belongs to z such that AU, that means 5u plus 12v, must be 1. Now we just put the value of u and v, will check, or you can apply the Euclid algorithm. So here we just put u value is 5 and v value is minus 2. Then 5 into 5, that means 25 minus 24, that will be 1. So here you can easily check your u is 5 and v is exactly minus 1. Okay, just you put the values and you will check minus 2. V will be minus 2. So now what is exactly given? Our Diophantine equation is 5x plus 12y equals to 80. That you will think in that way, 5x plus 12y equals to 80 into 1. Okay, so 80 multiple 1. So 5x plus 12y. So 80 in position of 1, we will write 5u plus 12v. So 5u means 5 minus 12, and v means minus 2. Okay. So that means we can write 5 into x minus 2 for x minus 400, and that will be equals to minus 12 into y plus 160. Okay. Now since 5 and 12 are prime to each other, so from that we can write x minus 400 by minus 12 equals to y plus 160 by 5. Why? Because since GCD of 5 and 12, this is equals to 1. So 5 must divide y plus 160, and 12 must divide x minus 400. Okay. So therefore we can consider as therefore x minus 400 by 12 equals to 1 plus 160, that by minus 12, that by 5 we can consider as an integer where t belongs to z. Why? Because 12 divides x minus 400 and 5 also divides 1 plus 160. Okay, so question must be an integer, so where t belongs to z, and from this we can write x equals to 12t plus 400 and y equals to 5t minus 160. This will be minus 12t. And what is t? Where t is integer, t equals to 0 plus minus 1 plus minus 2 and so on. So So thus we got the general solution. Thus the general solution in integers is given by x equals to minus 12t plus 400 and y equals to 5t minus 160. Notice t where t is basically integer 0 plus minus 1 plus minus 2 and plus minus 3, so on. So now we'll come to the second part. First we find out the general solution in integers. Now we need positive integer solution. So solution in positive integers. So for positive integral solution, what we must have, okay, so x must be greater than 0, y must be greater than 0, and x comma y both will be element of z plus basically. So that implies x means minus 12t plus 400. This is greater than 0, and 5t minus 160. This is greater than 0. That will hold simultaneously. And from that, what we will get? 32 less than t less than 100 by 3. Okay. And if we draw the number line, and here 32, 100 by 3, 100 by 3, so that will be 33.33 something. In between there is only one integer, this is 33 in between. So obviously that implies t equals to 33 since t is an integer. Okay, so we'll get only one positive integer solution. So therefore the only solution in positive integers corresponds to t equals to 33, and the solution is you just put the value of t equals to 33 here you will put the value t equals to 33. What you will get? Your x will be 4 and y will be 5. Okay. Now in similar way, we can calculate the next problem. Next problem, find the general solution in positive integers. So this is problem number 5. This problem is also very, very important. Find the general solution in positive integers of the equation 12x minus 7y 12x minus 7y equals to 8. Okay. So how we'll solve? Initially the problem was in the form of ax plus by equals to c. Now ax minus by equals to c. But okay, the process are basically same. Since here the given Diophantine equation is 12x minus 7y equals to 8. Okay. Now you will see, you will find out the GCD. So if you have given the equation of the form ax minus by equals to c, in first your work you will find out the GCD of A. And you will check that divides c or not, you will check it. So since GCD of 12 and 7. This is basically 1. And that must divides 8, so it has a solution. So from that we can write there exists integer u and v belongs to z such that AU, that means 12u plus 7v, that must be 1. Now you need to find out u and v. Just you will try by putting the value of u equals to 1, 2, 3 and so on, and v equals to 1, 2, 3, and also plus minus 1, plus minus 2, plus minus 3, plus minus 1, plus minus 1. In that way you can check. So here you will check. Here your u will be 3 and v will be minus 5. Otherwise you can do the Euclid algorithm, and from that case you can find out u and v. Okay. So now what is exactly given? Now it is given that 12x minus 8y, 7y equals to 8. And that we can write 12x minus 7y equals to 8 into 1. And that we can write 12x minus 7y. This will be 8 in position of 1. We write 12u plus 7v. So 12, what is u? U means 3 minus 7, what is v? V means minus 5. Okay. So now we just separate the variable. The x comes in the left side and y will move to the right side. So then 12 into x minus, that implies 12 into x minus 24 equals to 7 into y minus 40. Okay. Now since, and that implies x minus 24 by 7, this will be y minus 40 by 12. And that is also integer, t belongs to z. Why integer? Because GCD of 12 into 7 equals to 1. So from this expression we can say, so what we can say, 12 divides y minus 40 and 7 divides x minus 24. So that ratio must be an integer. So from that we can write x equals to 70 plus 24 and y equals to 12t plus 40. What is t? While t is an integer, so t may be 0, plus minus 1, plus minus 2, plus minus 3 and so on. So what is our general solution? Thus the general solution in integers is given by x equals to 70 plus 24 and y equals to 12t plus 40, where what is t? T equals to 0, plus minus 1, plus minus 2, plus minus 3 and so on. Okay. So in that way you can solve this kind of problem. It is very important in the graduation level examination. All the question is basically for 5 marks or 3 marks question. All the question is 3 plus 2, 5 marks. Here it is also for 2 marks question. It is again 5 marks. So all the question is basically either 2 or 3 or 5 marks. Now we come to the important statement of the theorem. The theorem is called the fundamental theorem of arithmetic. So this is also important question. Question number 6. State the fundamental theorem of arithmetic. The fundamental theorem of arithmetic. So this is basically for 1 marks question. How to state the statement? We need just one statement. No proof is required in this course. So statement of the fundamental theorem is not in algebra, fundamental theorem in arithmetic or of arithmetic. Okay, so fundamental theorem of arithmetic. What is statement? So if you have asked the say any integer, you can say 1, or you can say 2, or you can say 3 or 5 or 7 in that way, or you can, if you write 4, so that can be written as 2 into 2. If we give 6, so that can be written as 2 into 3, or you can write it 3 into 2. You have given the 8, so you can write 2 into 2 into 2, so that means 2 cubed, 2 square. So that means what we have seen, if the number is integer is either 1 or any prime number, or you can write the product of primes. That is basically the fundamental theorem. So any positive integer is either 1 or a prime or it can be expressed as a product of primes, But okay, in the representation, say as for example, you have given 12. So you can write 2 into 2 into 3. Someone write 3 into 2 into 2. Someone write 2 into 3 into 2. So the representation are basically unique except for the order of the prime factor. So this representation is exactly unique if we not consider the order. Okay, 3 comes in first and second or third. So that's why the product of primes, the representation being unique, being unique except for the order of the prime factor. If we remove the order, so in that case the representation will be unique. So except for the order of the prime factors. So this is basically the fundamental theorem. Okay. So fundamental theorem actually help us to write an integer in canonical form. So why the advantage of the theorem? We think about the advantage of fundamental theorems. One of the advantage is, I am recall. So that recall will be our recall 5. This is our advantage. Advantage is we can write any integer. We can write any integer n, and this is greater than 1 in the form. The form is basically called the canonical form. Canonical form. And the question, what is the canonical form? So n equals to p1 to the power alpha 1, p2 to the power alpha 2, pk to the power alpha k, where pi's are distinct primes with p1 less than p2 less than pk minus 1 less than pk, and all the exponent, that alpha 1, alpha 2 and all alphas are positive integers. Okay. So here, as for example, say if you take 24, so that you can write 3 into 2 cube, or you can write 2 cube into 3 to the power 1. So that means p1 to the power alpha 1, p2 to the power alpha 2, while p1 equals to 2, p2 equals to 3. The relation is like this, and alpha 1 equals to 3, alpha 2 equals to 1. All are basically positive integers. So in that way, this is basically the canonical representation of a positive integer, and that we can write with the help of fundamental theorem. So this will gives us in many portion, it will gives us advantage to calculate, say, Euler function, tau function, like this.